I'm Lauren, and this is Luna, and today we're going to be talking about basic Ramsey theorem. So we're just going to introduce Ramsey theorem for prospective mathematicians, for new mathematicians. We're going to talk about the theorem itself and some of the notation that's used for the theorem. So when we say Ramsey theorem, it's a theorem about placing a coloring on finite subsets of a set. So we look at all of the finite subsets of a certain size. So we'll say subsets of size 2 or subsets of size 3. We're going to look at all of the subsets of that size, and we're going to place a coloring on them. So Ramsey theorem says there exists a monochromatic subset. So let's see what that means exactly. So before we state the theorem, we're going to look at an example just because there's so much notation in the theorem, it's easier to have something to refer back to so that you can understand what we're talking about. So I'm going to look at a set of size 5. So this is finite Ramsey theorem deals with subsets of a finite set. So I'm going to look at a set of size 5. So that's going to be my n in this problem. So sets of size 5. Or one set of size 5, and I'm going to look at all of the subsets of that set of size 2. So I'll label my elements 1, 2, 3, 4, 5, and then I'm going to look at all of the 2 subsets of that. And notice there's going to be 10 of those. So we'll say if you have 5 elements and I want to know how many 2 subsets there are, I'll say 5 choose 2 is 10. So there are 10 2 subsets of 5. So I've listed them all here, and then I'm going to place a coloring on them. So Ramsey's theorem is about colorings of 2 subsets or 3 subsets or k subsets. So here's how my coloring is going to work. I just made some of them red and some of them blue. So this is a 2 coloring on the 2 subsets of 5. Some people will represent this with what's called a complete graph. And I know if you're just getting into math, you may not have heard this definition for a graph before. It's just a collection of vertices and edges. So here's what we'll call a graph. So I've got 5 vertices, and then I'm going to draw edges between the vertices. And it's a complete graph if between every pair of vertices there's an edge. I may have switched up the words edges and vertices there. So these are the vertices, and now I'm going to draw in the edges. So I noticed between 1 and 2, I'm going to put a red edge because I decided to color that subset red. And between 1 and 4, I'll color that red. 2 and 5 was red. 3 and 4 was red. And 3 and 5 was red. And then the rest of them were blue. So between 1 and 3 was blue. 1 and 5 was blue. 2 and 3 was blue. Oops, I accidentally made that red. 2 and 3 was blue, 2 and 4 was blue, 3 and 4 was red. Okay, 4 and 5 was blue. So this only works for when you're looking at size 2 subsets. You can color the edges to represent size 2 subsets. And this is a complete graph, which means I have colored every possible size 2 subset. So sometimes when you're dealing with Ramsey theorem, you'll have graphs to go with it, and this is how they work. We're just looking at subsets and we're coloring those subsets using the graph. So the question that we're trying to answer is there a subset of size 3, which is monochromatic? So that means when I look at these 5 elements, I want to find a subset of those 5 elements, maybe 1, 2, 3, maybe 2, 3, 4, just a subset with size 3, such that all of the 2 subsets contained in there are the same color based on my coloring that I decided up there. So let's look at that. So let's see. So once again, I've got all of the subsets of size 3, and you'll notice there's 10 of them. So I've got all of the subsets of size 3. And then I look at the 2 subsets contained in each one. So in 1, 2, 3, I had 1, 2, 2, 3, and 1, 3. And then I looked at how I colored them above and carried down the coloring. So 1, 2 was red, 1, 3 was blue, and 2, 3 was blue. And what I'm going to observe here is that this is not monochromatic. Monochromatic would mean all three of those were the same color. So I'm going to say not mono, and then I'm going to use this Greek letter chi. So we'll start getting used to that. So that's like for CH, and it looks a lot like an X. So that means it's not monochromatic. So notice none of these are monochromatic. What Ramsey's theorem is looking at is if we started with a bigger set, could we have guaranteed that we could find a monochromatic 3 subset? And there's lots of videos proving that, yeah, if you're looking at 3 subsets on a 2 coloring of 2 subsets, then yeah, 6 is the number you want. Ramsey's theorem is not actually involving the number 6. Ramsey's theorem is just saying, yeah, there exists a big enough number that we can find a monochromatic subset of size 3 or of any size. So let's just demonstrate what that would look like, and then we'll state the theorem. So 6 is big enough. So I'm just going to take an arbitrary coloring on the 2 subsets of 6. So here's all the 2 subsets of 6. Let's see, what do we have? 1, 2, 3, 4, 5, plus 4, plus 3, plus 2, plus 1. So we've got 3, 5, 6, 10, 15. 6 choose 2 is 15. I've got 15 2 subsets, and I've put a coloring on them. And since they're 2 subsets, I can represent this with a complete graph. So I've got that over here, the complete graph that corresponds to it. And I want to try and find a 3 subset that is monochromatic. And 6 is the thing that works. So no matter how I had colored these, I picked this particular coloring, but no matter what coloring I had done, there exists a subset of size 3 such that all of the 2 subsets in it are monochromatic. So again, let's just look at it so you can get an idea of what it is we're looking at in general before we state the theorem. And the theorem, again, it's just an existence theorem. So yeah, there's plenty of ways to prove that 6 is your number, but that's not Ramsey's theorem itself. Ramsey's theorem is just saying there exists such a number. All right, so I looked at all of the 3 colorings or all of the 3 subsets of 6. So we have 20 of them. I looked at all of those 3 subsets, and in fact, for the coloring that I chose, not only was there 1 monochromatic 3 subset, there were actually 4 of them. So I guess this was a kind coloring that I chose. So you'll notice 1, 2, 4, that's a 3 subset that's monochromatic in my coloring. 2, 3, 6, that's another 3 subset that's monochromatic. 2, 4, 5, and 3, 4, 5. So I had 4 monochromatic subsets. Okay, so that's what it looks like. So now let's state the actual theorem, and we'll hopefully be able to understand what all of the variables and everything's referring to. So here's Ramsey's theorem. It's just extending those examples that we had above. So it's saying no matter what m we choose, so the m we chose above was 3. So no matter how big we want our monochromatic set to be, and no matter what k we choose, so no matter how big the subsets are, so we chose 2 for our subsets before, so we made our subset size 2. And no matter how many colors we use, so we just used 2 colors, but we could have used 3 colors and we could have used 4 colors. Ramsey's theorem is saying no matter how big each of those are, there's always going to exist a big enough n such that for every coloring, there is a monochromatic subset of size m. So let's just talk about what those notation symbols mean. So the first one I want to point out is this symbol right here. So when I just look at this thing, the brackets around the n, that just means all of the numbers between 1 and n. Or if you're starting your natural numbers at 0, it would be between 0 and n minus 1. So I'll say 1 up to n. That's this set. And by putting the little k up here, that just means the k subsets. So in the example we were looking at, Rn was 6, and we're looking at a coloring on the 2 subsets of 6. So we look at a coloring on the 2 subsets of 6, and we just had 2 colors. So our R was 2. And for this particular n, we could always find a subset, which we'll call M, and the size of M is little m. So in our case, it was 3. That's monochromatic. So let's just look at this bottom example right here. In this case, we could say M is the set 3, 4, 5. That's a subset of this bracket 6. And if I look at my coloring, and this little symbol is just called a harpoon. So it's a restriction. If I restrict my coloring just to 3, 4, 5, all of the 2 subsets on 3, 4, 5, then I'm just going to get one color, which let's say blue was color 2. And that's all Ramsey theorem is saying. It's just saying no matter what the M is, no matter what the K is, no matter what the R is, there exists an N big enough that this holds. And if you want to talk about how to find that N, or if you want to look at the infinite case, those are all applications of Ramsey's theorem, and we could go on with that further. But for now, that concludes this video. Thank you.